Sir, what happened there? Can you please say first?
Okay, we will wait about 3 minutes and we will start. Kindly close your mics and video. We will start in 3 minutes. And please try to close your cameras and mics. Okay, we will start right now. Welcome to today's webinar on Servback free session. My name is Marwa. With me today is your presenter and Servback champion, Nadir. Today's session, we hope that you will learn about the main feature in Servback, and we will have a little time for Q&A after the session. You can raise your hand, and I will open the mic for you, or drop your question in the chat box. Now I'll hand over to Nadir, who will tell you a little bit about himself. Here we go, Nadir.
Hi, good morning, everybody, and also good evening if you are behind the time. So today we will start our free session in Servback, and we'll let the people start with the software. After this session, you will be able to work with Servback software, and also you will be able to generate many tasks in Servback. The presentation today is provided by Servback company. This is standard presentation, and we will guide through this presentation. Also, we'll work on Servback. I think we better start right now. Then our session today will cover about 3 aspects: introduction to Servback. That will cover the concept and file operation, and we cover the CAD tools, data creation, and how you edit data, how you display and hide the data in Servback, and data management, how to do section and plans in Servback, and also we can jump to the geology, and then we show you how to work with the drill holes, how you plan for drill holes, and also we'll go to service and solid modeling, and after that we go to also guide you through how to do a resource modeling and resource estimation, and also we'll guide you through how to implement a grid control or do a grid control in open pit mine. After that, we'll jump to the engineering and we'll show you how to do pit design and dam design. And also we can get introduced to road and ramp design. And also we will show you how to generate a blast design and also volume calculation and reporting. This session is for geologists, for engineers, and also for surveyors. It will be helpful for all. And as you see, this Servback is the world's most popular geology and mining software. Geology and mine planning software. In addition to Servback, you have Minesheet and also Whittle, and this is combined with Servback. Any software has its own purpose, but they integrate together to get a powerful solution. So Servback delivers efficiency and accuracy through ease of use. They have a very powerful 3D graphic, and you will show this now. And also you have a work automation, and you can make your own automated or process. So the benefit from Servback includes comprehensive tools, support all mining process, as we say. Also, will increase your efficiency for better sharing of data skills and project knowledge, automated task, modular and easily customized. You have many models in Servback, and you can easily customize all this model. So the input data for Servback can accept any type of data from any software, like AutoCAD, like DataMine, ArcGIS, Shapefile, Volcan, Micromine, MineSite, text file, CSV, from games, from MapInfo. All this type of data can be easily imported to Servback, and we'll show you and demonstrate that one. The Servback data type is the main data type in Servback is the string, and we will go and see what string. And also you have the DTM, and if you can see here the example of the string is sequence of 3-dimensional coordinate. We will go through it now, and also the DTM, your database, your survey database station, the block modeling, and this all is the data type in Servback. DWO for drawing files, and you have the macros and DXF. The plugin is different, like this one here, we call it a plugin. If you have any data from different software, there's model in Servback, they call it plugin. You can just drag and drop and it automatically will open the file for you. The plugin file, if it will appear like this symbol here, if it DXF, if it .dm, if it .shb file. And finally, we have the style file. The first thing we need to understand is the Servback interface. So first time you open the Servback, the interface will be like this one. So you have the menu, and you have the toolbar, you have the command bar, and you have the status bar in here, and you have the layer bar, you have the navigator bar, you have the legend, and you have the properties bar. The interface is very simple, and we can show you how to work with this one. And the powerful of Servback is to use it through the toolbars. Then we show you how to do the toolbar just right now, but we need to go back to the presentation and see one very important concept is the string. So the string file is the most common file format used to store information in Servback. So we will work with string. Almost of the time, we will work with the string and segments. In order to understand Servback, you need to understand this concept, the string, segment, and point concept. A string is file contain coordinates, information for one or more points, as well as optional descriptive information. So you can store any attribute or any information inside this point or segments. This will enable the work to be more efficient. Let us go, and if you can see in the left, there is a string file. The string file is already contained with different string. So the string file as file is contained from different string, and also the string is contained from different segment, and also the segment they have group points. But the point the point group their segments. So now we have the main file is string file. This string file is subdivided to segment, and that segment contain points. So let us see in action in the Servback so you can understand better. So for example, we call it a Servback string. You can see it's just one string. This we call it a string, and also in the same time is segment. If I just display the string number, you can see here the string number is number 1. Also, this one is segment also. So if you can display, so if you are display with string and segment, they tell you that it's string number 1, segment number 1. Then if, for example, if I do another one, you can see it's already get that is string number 1 but segment number 2. And also if I draw another one, it tell me this is string number 1, segment number 3. And the 3 the three, all of them, they store in one file. If you can see the graphic layer, we call it string. So for now, if I come to the Navigator and set this as directory, and then I save this file, so you can see here, this file is now a string, but this string contains of different segments. So this until here segment 1, segment 2, and segment 3. And if I display the points, so you can see now the point. The point is just start from 1 and to the end. It's not related to any segment string. It's just count the point. So for example, they start from 1 and end in 25. So this is just count. So now let's start with the Servback interface and how to set up your Servback interface after we understand the string. To use Servback, you better use it through the toolbar. So we have two most used toolbar. Is display and hide. This will allow you how to display and hide the data. And also you have another toolbar, we call it edit toolbar. These two toolbar is very powerful. And for now, it's very easy for you to work for Servback from here rather than go to the main menu. We will go and dig through this main menu and explain one by one. But for now, if you understand these two toolbar, how to display and hide and how to edit the data, that will be very powerful. Let us now go in the Navigator. You can see here, this is the Navigator where you store your files. This Navigator is already built in your D drive or C drive. So now you work with real data here. For example, if you delete any file from here, you will delete it from your drive. For example, like this, I already deleted from the drive. So be careful when you're deleting your data, because it's not storing memory, it's just direct storing your local file. After we go after the concept, just now show you some of the string. For example, this type of string. We have this string also. A string can represent any shape. Can represent even bit design with different string. For example, if you can see here, now I will use the toolbar. I will use the display and hide toolbar. Now I need to see the string and segment number for all points. Just first point. So for now you can see here, this is string 1 segment 1, string 1 segment 2, string 1 segment 3, string 2 segment 1, string 3, string 4, and you can see any string has different color. And this is how you work with Servback through segment and string. We have another file, is a Dtm file. So the Dtm file is triangulate file, is constructed from the string to generate the services. And these services can later allow you to calculate volume, and this service is very important. Also, you can store sample files. For example, if I hide all this sample and just display the points, and we can just load the description from D1 here. So you can see, you can store maybe this soil sample or blast sample. This sample, it has elevation. And this interface, it has a grid in the background. You can see the grid coordinate can be local coordinate or UTM coordinate. So for now, later on, we'll show you how to work with level. For example, this is stored in level 100. Can be a bench, can be anything. Also, you can store a solid model, can represent a volume in the subservice. Can represent topo, and you can represent any type of design. So let us now do one exercise, is how to import, how we can import elevation point to Servback. If you have an Excel sheet you have this Excel sheet contained with X, Y, and Z data, and this represents a topographic survey point. How we can import this one to the Servback? So this you need to save this file as CSV. Then from here you can come and do import data from one file or text or CSV. Then when you enter this, will show you will tell you to open the CSV file or text file, and then you need to save you need to give it name and save it in location. Abbreviation. Then we save this one. So here they tell you if you have any header line. So if you can see, we have a header line. So number of header line is 1. So he will skip this header line and will just get the XYZ for you direct. If you have any description field after the Z, you can tell him or tell Servback the number of description field that you have after the Z file. For example, if you have in this point, if you have a grade of any minerals, or if you have any description, you just put it there. So for now, if you press apply, then here Servback need you to define which column is referred to Y coordinate, which column is X coordinate, and which column is Z coordinate. And if you have description field, this one will appear, and you need to tell him what the file is, the description field 1, description field 2. So for now, in that location, I think the X is number 1, the Y is number 2, and the Z is column number 3, and then we apply. Once you apply, it will be saved here. It's a topo. Then you need just drag and drop that point. So now if you need to see this as point, you just hide the string and then display only the point. And now you can see this is represent a topographic point. Can be taken by a surveyor. In order to transfer this one to a DTM, it's very simple. Before we have one point here, you can delete this point by just came here and delete point, or you can go to point, edit point, and then you delete. Waiting for delete that point. Maybe it's many points on top of each other. So this may be contain of many points. So let us number this. If you can come here, you can see this a lot of points above this one. You can just select like this one and then just delete it. Because if you click 1, 1, 1, if a lot of duplicated points in front of each other, it will take time to click. So you just select them, and so now you have your topographic here with all your points. If you need to transfer this to a service, you can just easily go and from service and create DTM from this layer. Yeah, so he doesn't accept any intersection. Patient points, and then create, and then apply. When you do the service, and now you create your services, and you can see the services is just construct from many triangulate. Every 3 point is connected to represent one triangulate. If you have more point, your triangulation will be more smooth, and also you will get accurate volume. For example, later on, if I need to calculate any volume by this service, if the service is a minute triangulate, will be good in representing the topography in 3D. This now how you will import topographic data, and also as example, you can also put plot an image or satellite image or any map and drop it to this service, and also this is very easy. You can. So in order to save this topographic, you can go to the layer and right click and just save, or from the file here, and then you just go and save string or DTM and just give it name or the same name as the strings, no problem. Just press apply, and then this one will appear here. I will delete this all now. Then I will drag the topo. For example, if you have image like this satellite image, and you need to drop this in this service here, it can be a map or satellite image. This also you just from file, you just image, they might drop image over this DTM. And if you can see in the down here, the yellow bar, the yellow flag in the status bar, it tell you what exactly need from you. Now they tell you to select the triangulate of interest. Then I will select this one. Now for now, I will just need to save the registration file, and this will save our georeference coordinate. I just need to drag the image, and then I will do apply. Then two coordinate will appear. For example, now if you know how to do georeference in GIS or in Leapfrog, you need to have a coordinate point, at least 4 coordinate point in the corner, and then you just map it to the corner here. But for now, I will just do it without any georeferencing, just to see how it will be dropped. So here they call it digitize registration point on the image in view port 2. This view port 2, I will tell him this location refer to this location, and this location here refer to this location here, and this location here refer to this one. And you need to make sure you go in clockwise or anti-clockwise. You cannot go here. You can maybe, but it's not recommended that you just jump and select point randomly. You need to go either clockwise or anti-clockwise. When you finish, you just click escape, and there's this your reference points in the image, and then you just click apply, and now you can see if you just hide the, then you can see this is your image in, drive it in the topography. If you can put any zone, you can see now this one here. Also you can put any design. Just need to put the light on. So the next thing we will see is how to make Servback legend. So to modify your legend, you need to go to the legend, and this legend is very powerful. You have a legend for the DTM, and also you have the legend for the service, and the DTM, this is the services. So when we say DTM, this the services, like this service. And when you say the string, this is string. For example, this bit design, any string has his own color, and also the thickness of the string. You can come here and generate your own legends. You can just go double click. You can build this one, or you can just go for customization, and here you can find the same. So in Servback you can find the command or these tools in different places. So for example, if you came here, then now you can see the string is already numbered from string number 1 into 2. Whatever string you need, you can define it, and you have already defined a string and polygons. If you do mapping and you need to reference that map, and you can use, for example, you can use Servback as GIS or MapInfo for mapping. So now in order to change the string, you can just come and double click and say properties. Then in here you can edit the color, whatever color you need, or if you know certain color, you can just write it red, for example, and then you press OK. Then this is the thickness of the line, the style, dash line or solid line, the joint type also, the ends. And just when you select your preferred lines, you just select apply, and then you can also edit the points. You have different point type. You can change whatever you need or depend on your styling standard in your company. Then also you can change the polygon. And after you change your style, you just came and save it here. You give it name and save it. You can save many legends as you need. And this legend is just for the string and for just for string and detail. For the block model legend, we'll come later to see it, and for also the drill hole legends have a different legend. So the last thing now, we just need to go and see how to do section in Servback, and this also is very powerful. For now, we can go and see how to put any 3D grid for this one. If you come to the toolbar, this is the display and hide toolbar. And as I tell you, the better way to work with Servback is through the toolbars. It's very easy, and all the required function you can just find it. The display and hide bar is just already here, but now we just put it there. And this is the edit bar. So from here you can go and display the 3D grid for this one. You can define the Y direction, X direction, and then you just apply, and then you get your direction. Also, you can make many viewport as you need. I can split this to 2 viewport. I can put this one. I can split this to horizontal. So as you need, you can just do. And this is good for designing. You can see from different angle how this will goes. The other thing, how to customize. So I will close this now. If you need to customize the Servback interface, you can just come to the customize and then default preferences. For example, if you need to change the background, it's from here. Graphic color, and just you can change it, for example, to white, and then you apply, and then it's changed to white. If you need any color, just came to graphic, and there is many setting you can change here. You have the display option, the temporary marker, the viewing, cutting edge, this for viewing, tool setting. You have the coordinate system. If you are in different country, you can just change your coordinate system. If you use a different measurement unit, you can change from meter to feet. You have the imperial or metric. So you have many things you can play on here. Also, you have the 3D view. You can make it as 2 color. For example, if you make it light color here, and then we just this now for the 2D window. We already changed to white. I will change another color, so you will just understand. I will make it red. Then we have this in red. Also now I will just I just need to change the 3D windows. I will retain this to white. Good. For example, if we make this blue and this is white, and then apply. So for example, now I change it to blue and white. But in order to get the 3D window, I need to go from here, toggle 3D background, and then you can see I am now in the 3D background. And then if I need to return back, I just go and 2D background, 3D background, and also I customize this one. I customize this one from here, and then we get this customized. So for now, I will just jump into the sections. So while we are working, you will be introduced to all these toolbars. For example, now we are just jump and click some areas. You cannot follow with us now. You just need to understand the concept, and then when you have this recording, you can just go and do it one by one if you have the software. So for now, I just need to explain to you the section method. You have 2 ways to do a sections in Servback. So use a classic method. This you can bring the classic slicing toolbar, this one, and you have the plans. If you would like to just generate a quick section, the classic one is good. But if you want to save sections, you can save this one. I will just bring the drill holes, or you can just sections through any solid, for example. Let us now section through this bit design with this also. For example, if you need to section this from the northern section or eastern sections, now I just need to know what is the limit here. I can start from 7120. I came from here, define section, the quick plan, or you can find it from here also. So you can find it from here, or you can just find it from here, whatever it is for you. And then from here in the orientation, you have maybe 3 or 4 type, northern, eastern, elevation, and oblique cube. Now we are doing northern section and looking north. We will start on 7100 and then here, and maybe make the steps about 40, and we'll generate divided this by 2. Then you just need to give it a name and give it a group name. For example, we just leave it as default, and then we snap to 2D plan. So once you go to the next section, is just up here. Then when you click apply, you can see now it's already give us section, and this section is just stored in the right here. In order to go from section to section, you just either double click in any section, or you can press F12 and F11 in your keyboard, then you can go. For example, if you would like to see just the intersection, you can come here, drawing triangulates or polygons as intersection. Now you can see the intersection between this one and this one. For example, if you have a drill holes here, yes, yeah, for example, we have drill hole, and this we work with it when we have a drill. For example, now you can see sections. Otherwise, also you can make elevation, and you can also make eastern sections. Yes, from here. The classic view, the classic slicing is also, you can just come here, and also you need to define what is elevation or graphical, northern, eastern. The graphical is very useful, and you can just graphic selection side, select section line. This will allow you to select where the section you need. So if you put this as 20, put the step distance 40, and then for now, after I click enter, you can see there is a yellow flag in the status bar, say that click and drag to define the plan. I just need to click and drag, not click and also click, just click and drag. For example, if I need to make section here, you can see, and from here I will just make it like this one. If I need to make section, this is a quick section. Let's make it 20 by 20. Then, for example, if I need it like this, and I see. So I think now we finished with the introduction to the Servback, and now we need to go jump to the next process, which is the drill holes. If you have any question in the introduction, we can just address it after that one. But you need to go through all this one, and it's very easy. For example, you can go and start digitizing or just generate different things. For now, we already know how to work with display, some of view and plans. We'll come to how to inquiry point, and we also will work with this one, the survey, and also we'll work now with database. We will come through all this menu. Don't need to worry. So before we jump to the drill hole, let me show you how to digitize a string. So in order to digitize the string, you have this toolbar here is digitizing. This will allow you to digitize the string. So in order to digitize string, you need to set elevation. For example, if you digitize without setting elevation, the string is by default will go to the 0 level. You can see by default is go to the 0 level. And also by default will be saving in the new layer. For example, if you need to create a new layer from the file, new layer, or from here, just click new, and you can save it as drawing. Then you apply. Then we come and define from this one here. We need to define the string number. For example, we don't need, if we don't need to draw by string number 1, we can, for example, select string number 100, and we need to digitize on level 1000. You can put description field too if you need. The sniping properties, we just show it later. It's very easy after you. Right. But for now, automatically we'll just snap to this plan 1000. Then you just click apply, and now everything is set. You just need to start digitizing by create new point using mouse, and then you just go and digitize the point you need. Once you finish, if you need to close this segment, you can go here and click close. You can just close the current segment, or you can just press 0 in your keyboard, and it automatically will close this one. If you need to see what the segment and string number for this one is, just easy here, and you can put it in the center. And this is string number 100, segment 1, and the elevation is 1000. What is the elevation? 1000 is here. So you can see this is in 1. This is 1000. So in order to snap, you have different type of snap. Snap to plan, to point, and to line, and triangulate. For example, if you have any, for example, if we have this bit design, and we need to snap to draw in this level here, you just need to get the point, and then you go and snap to triangulate, and you can now come and digitize here. Now you can see you are snapping to this triangulate. So if I go save, then from now you can see I already digitized that one, the string snap to that DTM. And also you can snap to line. For example, if I would like to go and snap to line, so if I remove this one and then came here, and I have already draw it line. So for example, if I need to draw another line and snap to that line, I need to go here and just snap to the line, and then once I click, he just snap to the line. You can see just snap to the line. You can also snap to the point here. You can snap to the point. In order to also change between this snap, you can just press number 1. This is snap to plan. Number 2 is snap to point, and then number 3 is snap to line. Number 4 is snap to triangulate. Also, you have number 5 here is a drafting. So if you need to make a drafting, just make it 3D so you can see. If I press number 5, so I can digitize by even coordinate, and you can see here in the option or toolbar you can define the distance you need and the snap limit. I think here, the angle you snap on and the distance you want. You can see it just give you 100. So now you jump from 100 to 100. This may be as good as CAD tools. You can just draw whatever you want in different direction. I think this is all for the digitizing. So I think we better now jump to the. Also additional, you can also select can also select this string to see the properties of a string. So for now, this show you the properties for a string. You have the 2D length, and you have if the string is clockwise or anti-clockwise, and this is also very important. So you need, if you click clockwise and if you click anti-clockwise, this we can see it later when you go to the design. I think for now we just need to go and come to the drill hole. So in order to create a drill hole database in Servback, and this for geology, you can create a drill hole database and you can do a drill hole management, compositing, section, and you can make the geological interpretation on all this stuff. So just go back to the 2D window. You have a toolbar here for a menu here for the drill holes. You can now create a database or map database. If you select map database, that means you have your database installed in, for example, in SQL or in Acquire if you have Acquire, or even in Fusion. Can you see you can connect many connections? You can use ODBC and then you can select the server you need and then you next, and then it will give you connect to your SQL database or Fusion or Acquire database, and then from that you just map your color location, color files and fields, and also map your assay like this one. Also, you have option to just you have option to get data from CSV, and as all the software, in order to bring a drill hole, you need a color file and you need the survey file. This is required. You cannot, because they represent the geometry and location. Because without location you cannot do anything. So now you have the drill holes. This is the drill hole information. These are coordinates, and these are survey and debalancings. So I will just quickly go on into this one. So in order to create a new database in Servback, you just need to go on here and select new database. Let's call it this one. Database, then it's just new. Then you give it name. Apply. Then you could to define your access file. If this not work with you, you need to install Microsoft Database Engine. I think it's automatically installed when you install Servback. But if you don't have, you just make whatever access compatible with you, because now when you generate the database will be installed in Access, and you can also install in through ODBC in any link you need. You need to provide connection to the ODBC and also this type of database. But now we'll just use Access, maybe 2000. And also you need to have this calculated y-axis, so you can desurvey the holes. You then need to provide this for example, in the interval between the sample. So this should be going to be calculated. Then apply. Then by default, the Servback will generate two tables for you, is the color and survey. And you have many optional. You can add many options as you need. So you have, for example, assay and geology, and this type of table. You have three type of table. Maybe you have interval. This is they have from to, and you have point. For example, if you have a soil sample or any type of sample with record at depth at, so you have one value at depth at, or you can guess as discrete values. Now you just go in interval and then you apply. Then from here you just need to define the color fields. Also in the field you have mandatory fields. So in the color you need to have whole ID, X, Y, Y, X, Z, and max depths, and this is mandatory field. I think now you have it. You can also add any optional field you need, like date, anything you need. So you have the survey file, and here you can also have mandatory field you cannot skip, and then you can just put optional file if required. Also here you have in the assay, you have also a mandatory field, and you also have optional field, and you can just add the optional field. For example, in the assay, we have AU, and this is the type of this one should be real. And you have many types here. You have integer. This is a number without decimal. Real, it can get decimal, and you need to define the decimal. If you need 4 decimal, 2 decimal, you can put memo on, also Boolean operation or characters. The characters always should be mixed. Maybe it can be letter and number. So for now, for AU, we just select real. For geology, if you have rock code, we just make it correct. You can define the length. For example, let's make it 15. And this you can keep it as it is. You don't need to do anything here. Just apply. Now you already prepare an empty database. So now you have empty MDB file. If you can see here, the Servback generates 3 files: DDB, database description file, and this LDB or loading database, and MDB. MDB is actually just empty access file to store your data. So for example, instead of this access file, you can have a SQL file or a Query file or any type of other database. You can just connect to Servback. Otherwise, if you don't have, you just can use access. This one. In order to import this data to the empty database, is just from here. And just import this data, and then you need to define the import file name. Import 1, for example. Then you need to define what file you need to import. You just need to import the color survey, assay, and geology. Then you just click apply. Then again, they will ask you what the columns for whole ID in that color CSV file. So it's whole ID number 1, Y number 2, and then X number 3. Whole bus, if you don't have whole bus, you just untick it, so it will not be included. And also for the survey, you need to make sure about your data. So for example, division number 3 as number 4. Yeah, if you are not sure, you just go back and take a look in your color. For example, now we have Y3 and we have next steps, we have sections. We will not import this one. And in survey, we have div and azimuth. Then you just come back and do this very quick imports. We have the whole ID as said there, and also here the divs. We have the div number 3. You can see it here. The div is column number 3, 1, 2, 3. So the div here I'll put it as number 3. Azimuth is number 4. Then when you go down for the assay, you don't have sample ID, so depth from will be number 2. Depth 2 is number 3. And AU is number 4. You don't have sample ID here. Also, you need to just provide this accurate. And then you just click apply. Then here we tell you to locate the file in your computer. Then you just go here and then select your color, survey. Because you said color, I already select the color, and set here survey, I select the survey. Here way to put your assay. Here way to put your geology. Then you can, if this is your first time, you just insert. If the second time, you just insert and update. If you just need to update, just update. But I think it's better you just keep it set and update, and then you apply. So sometimes Servback give you like these errors. So you can see whole bus is not allowed. That means we mix up the numbering. So we don't have any whole bus here. That's why we need just to go and go back and just write again. You cannot go to the first one. You can just go generate another imports. Sometimes also can give you it not accept a lowercase. That means you just go and change the whole ID to uppercase, uppercase character. There's another error we'll give it to you. For now, we just have a problem with the file path. We don't have whole path. This one here, you just need to unclick that one. Before the whole path is character, but this one here is numbers. But we don't have that one. This is all the problem now. Here we don't have this one. If you have sample ID, you just keep this one. 1, 2, 3, 4. 1, 2, 3, 4, and then max steps. And the same. You can see now it's just import it all. And you can see it's already reject the file number of the first line. First line because it's already have the header. So it's just reject the header. One is rejected and accept the 94 column. And also here header is rejected. So here what they said. They said also you contain illegal lower character. And now this is good. We have all these problems, so we can go and solve. Because this problem will happen to you if you are first time importing the database. So they said that depth from is not numeric. So depth from should be number. Then for now we already upload that one. Then now we need to go and work with a save file. So if you get a save file, yes, here the problem, because we have sample ID in the save file, the depth from is not sample ID, so it didn't accept that one. So now we need to go and map the file, the column correctly. Let us see also the geology. The geology is not without ID. So for now we just go and load database again or import database from here. Then we can go import number 3. And here we don't need all of this. We just need to import the assay and geology, just to these two files. Then now we know we already have sample ID, so we don't need to do anything here because we already have sample ID. And also from the geology we don't have sample ID. Then we'll just remove that from here and change this to 2 and this to 3 and to 4. Then it's okay. Then here we need to bring the assay, and again here the geology. Then you apply, and all is good. Then this one inserted and this one inserted. So the next step is go and define the legends. In order to go and define the legend for this one, for example, if we display now to see how the drill holes, so this is your drill holes. You can add our topo. Remember the topo that we put from the first one, this one. So now this is our topo, and this is our drill holes. It's imported from that CSV. But now, in order to see this with style good color, we just need to go and display style. Just from down here, you can see now the database is connected. That means the Servback make a connection file between Servback and your access file, because this is just access file. It's Microsoft access file, and now we just establish a link between this access file and Servback. And this link also can be established between Servback and SQL, between Servback and Acquire. And now let us define our style file, or we can also come from here. Yeah, this one, drill hole display style. Is same as a drill hole legend. If I go to assay, I know that the gold value I just saved here you can have many fields. For example, you can have for AU, for copper, silver. Just from here, you need to press get min and max range. Now you can define your grade boundary. For example, I will put about 5 grade boundary. The first one I will put the value from 0 to 0.3, and 3 to 0.8. Now let's make it 5. 1 to 2 to the seal plus 1. So I can give it color. For example, this I will make it gray. This maybe is green. Maybe it's blue. Red. Yellow. Also, I can go for the geology and just from in rock code, I will just get field code and he will give me the field codes. Rock number 1, I will make it, for example, blue. Reds. Let's make it as green. You can just select or just this I will make it or right yellow, and of course I will make it yellow. After I set the geology style and gold style, you just need to click apply, and then from here, in order to display this in here in your database, you just came from here and display drill holes, and this menu will appear. Contain with about 6 tabs. So the first one is just for the trace, the green one here. You can change the trace. You can color the trace by assay, for example, by assay results. If you click apply, it already automatically colored by the assay results. For example, if you need to make it as a cylinder, you can make a cylinder, and now you can see it as cylindrical with difference. In order to see the legend here, you can just come here and you can see your legends. The gray is west, as we have the legend here. If you need to have a variable cylindrical, we will just work with the trace. We can make it variable width. Then we apply. Then for now, we just know where is our super high grades and where is our medium grade. You can put your topo, and then you can see. Also, another way to do this one, we'll just cancel this. And as you can see, it's just empty. Then the color style, you can also put the hole ID. I will put it in the end of the hole. And 2. This will generate the hole ID in the bottom here. You can see which hole, and also you can also put it in the color if you want. Then from here, we can also color by the geology, by the rock codes. Center, we can make width as 4. And now I'm going quick, but after this, we'll have a recording for this one. You can just go slowly on this one. Now you just understand the concepts. So now we already covered. If you are going to our previous sections here, you can just see the section. Now we can have the geology legends. So the quartz one is the yellow one. So we know that is one here. You can just go through various sections and then you can see. Also, you can display the gold value from label if you don't want this one. You can just display this as label, and the label you can take as a part per million, and you can put it in the right. You can just get the rock code and put it in the left. The offset is where to write the label. For example, you need it offset from the drill hole, just inside the drill holes. Yeah, everything's set. Then we just click apply. Then we came here and you can already see the rock unit with the grid. Then now let us go and make offset so you can see it better. So we came here and adjust the offset, for example, 3. Then now we already have this geology with the full value. You can see it in 2D window. I just toggle from here, from between the 3 and 2D window. Also, if you'd like, you can just change the background to be black, as we said in the beginning. Then you can just see this one here. You can make your sections. Then now you already have your data. Let us make a proper section for the drill hole so we can, I will just delete this one. And then I will just make another section. Northing. Let me, I have kept it here. 7120 and 7600. Then it's 40. You can make it 15. You can give it any group name. Let's leave it like this. So for now, you already have the sections, and now you can start digitizing your ore outline. If you need to move from sequence, for example, now the yellow one is already the quartz vein, and the blue one is your intrusion, and then you have here contact between two rock type. And from here, you just need to start your digitizing. But before you start digitizing, you need to understand the geology, because this interpretation can be also misleading. You need to understand the geology very well, and also you need to have your mapping. So you need to draw your detailed maps in the top of here, and then you can just come and work your interpretation, because sometimes this one is very complicated. It's not the simple as you can see it here. In real data, this one is very complicated. So if you are digitizing, if you create a new layer, and for example, you need to digitize a bin. If you do this step and came with the digitized tools here, so for now in the digitized tools, we don't need to set any thing, because now it's automatically snapped to plan, and then you just need to come and digitize your boundary. This we call it explicit modeling, and you have another one is implicit modeling, like they have in Servback, they have a dynamic shell. I think they have dynamic shell. Yes. Dynamic shell can create also the same as leapfrog shell. I think from here, I don't try it, but you can go and try. And also you can use another software, new commercial software like leapfrog is good on implicit. But for now, let's go with the explicit and then digitize this one. In order to digitize, you can snap to the points now, number 2, and then you came here, snap to this point, then this point, then this point here, then here. And then from here, if you have mapping, you know where this fin end. You can press 4 and snap to the topo, then 1 again. So now I'm pressing 1, 2, 3 for the different snapping, like snap to point, snap to line, and then I will come again and snap to points, 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 points. Then here, snap to find. If this is vein, can be, yes, vein from login. Again, I will just go back. Yeah, when I came here, I can press 0 or just close. So now you have your first outline, then you need to go to the next section and do the same for this one. Again, you can do the same. Here you don't have anything. Just recommend it to put in the middle. Then here you set it on. And then you just press 0 to close this one. If you close your sections, then you know how you have to outline that you digitize. So you can see from here, it's just your outline. You need to complete all that interpretation even for the geology. Then you need to make a domain for your diorite on the dikes, meta-sediment, and then if you understand the geology, you can build your geology model. Okay. And then this will be seems like this one. We can go and just see that this fence. If you finish, you will just have your domain like this one, and the other one is be like that one. So now after you digitize all this per section, you will have this fin. And also for the other geology units, for example, like just put so another unit is here is very big. At what cost that mineralization? As you see now, we already have string, and now just go and see. For example, if you need to hide the database just from here, you need to come and just display and hide all drill holes. And also it's very easy to bring the toolbar for the drill holes. So now you have the toolbar for the drill holes. You can even query. For example, if you need to query some point from here, identify hole, then you will get the result here. You just click here, then you will get this what the hole ID, and then you can just capture it. So you need to go back and do all this step by step. Now we will just cover, no, we will not cover it all, but now this will just let you start. So for now, after we generate our digitizing, after you complete your digitizing, that when you will get a shape similar like this one, and then from here you need to create a solid model. A solid model is just a volume represent that interpretation or vein. So for now, if we display the string and segment to see, for example, now you can see here this is segment 1, string 1, segment 1, string 2, and they all have the same string. This also they can be different string, but now you have different segments. So this is segment number 1, segment number 2, segment number 3, number 4, 5. All of them we call it as a string, and the one of this one is called a string. I hope you understand this concept. So if you display the point number, you will find the point number is just series of points. So let me just display point number of you. You can see the point maybe start from here and just if finishing, for example, here starting the start point. Yes, it's here. This is number 1 and at the same time is 52. Then in this one will be start from 52 and continue, and then continue to the last point of your digitizing. Height. So for example, if I just need to display one segment from this segment, I can hide all segment from here, or you can just write ERS in the keyboard. When you write ERS, it will get clean. And then when you come to display the segment, you can define here the string range. So the string range, you need to define the string and segment or the string range. So for example, let us say that string number 1, segment number 4. We just need to see that one. Then we apply. Then he bring that string here. String number 1 was a segment number 4. Let's see the segment number 4. And 4. Yes. So now this is string number 1, segment number segment number 4. if you would like to display all, yes, and you hide that one, and then you just display all of them again. So in order to generate a solid model, you can just go from the solid here. The solid tool is the Servback have good documentation on this one. We can also do the we will not cover all of this. We just make it the simple. You can start triangulate between this segment, but before you start triangulate, you need to have a good view of all your segments, because you need to select one by one, and you have many way or method to do triangulation between this one. Then for now, we just select between segments, and as a string, the service has also set object number and translate number. Object, for example, number one, you can has translate 1, translate 2, same as string and segment concept. Then you will just start your digitizing. It's not digitizing, just linking. If you can see here, he is just linking the points to create the 3DTM. Then you can just continue. When you finish, you can see that solid is already have 2 gaps in the both end. Then now you need to close this entire size. Solid triangulate is just, you just need to close this one between segment. Then you need inside segment. Then you just select inside segment. You need to give it the same object and translate number. Then you just come and press here. And when you press here, you can see it's just closed. So this now is closed from here. So now this has become a solid. Servback also have a validation tool. You can just go and validate or solid repair. If this solid is not have any problem, will just appear here. For example, if I close this one and then I just delete one triangulate from here, let me just select. If I just delete this one and then check the validation of this solid, he tell me that there is two. He told me there is 2 triangulate open. And this validation tool is very important when you work in mining, especially in the underground. You will have the CMS data need a lot of validation. So these validation tools, and also you have more advanced validation tool, the auto repair. This also is very good. You can just come here and select the solids, just make close solid, and he will just fix it for you. If I go Endo and go with the validation tool, I can from here just come and click. You can delete, or you can just have many options to validate that tools. Then just click and it's already valid. But all of this work is not saved. If you can see in the layer here, the layer bar we have the ore zone, but the red one means that is not saved. You have the log. If you log this one, you cannot edit this layer or display and hide. You can display this and hide it, and this small green arrow means that is active layer. So for now you can save it from here, or as I tell you, from here, and also from the toolbar here you can just go and save this one aside. Let us put this here, seems better. Toggle this inside this here. So for now, in order to just you can also see the volume of these solids. Very easy. You can go to the solids, report volume of this solid, but you need that solid to be safe, or even I think from here you can do it. You just give it a report name, volume 1. In total, you can limit it by interval or by elevation. Later on, I will show you how to set elevation range, how to write it. And you just apply and give you the volume. So this volume here is about 2 2.5 million cubic meter, this one. If you multiply by the density, and then you can get the tons. So let us move now and see how we can start working with, how we can code this horizon back in your database, because in order to go, why we are creating this solid, just to create an estimate and useful information for the engineer, because now this you just have created the orbit outline, but this information is just useful for now for the geologist, not useful for the engineer. In order to become useful for the engineer, you need to put a lot of parameters, and you need to have a one communication units or one communication platform. We call it the block model. So we need to convert this 3D representation of the sub-service, for example, the vein, to a model or a cube models. We can just see it now, and this can be easily calculated for all the stakeholders in the upstream in the mine, or like the engineer, the surveyor, and all these guys. So the first step, we need that intersection information inside this drill hole. So how to flag this we call it domain. How to flag this domain inside your drill holes? This also is very easy. Just set this as well directory. Then you came here from the solid tools, and then you can get a drill hole 3DM intersection, and then we'll code your domain to the drill holes. So you already know that you already digitized this one from the geology, but sometimes the geology, it cannot represent that the grade, so you have different grade from the lithology, because different domain, or you combine multiple domains. So you need to flag this back to get the sample information within this data. So it's very easy. You just need to go here and click apply. You don't need to consider data. Here he will automatically pick the object ID, this object number 3. Then the output result will be in the main graphic layer to see where the intersection. Here, where you need to save that intersections. If you need to in the geology, if you want it in the say, and what the fields. So in order not to edit the actual tables, you can just come here and generate your L table from database administrator, and then we can create a field within table, or we can just generate a new table. So for example, let us create field in that say, and we call it domains, for example. And we create character, and then apply. Then the same step as before. You just call the solid. So in Servback, you don't need to memorize anything. You just need to understand how to work with it, and then you just come and locate. Because once you memorize any software, you will just forget it. After you finish the training, if you don't practice it, you will forget it. So it's better for you just to understand the concept, and then you go and locate. Because, for example, now this one, I can locate it from Drillhole 3D intersection, also from the service. I can find it. See, from services or from database, yes. So from database, you can also find this one. So you need to know what you want. Then apply. This is what directory. Then you already generate field. Call it domain. Then what the code? We call it VN1, for example. VN1. So for now, he give us a report. Where is the intersection of this solid with the drill holes? This is the intersection code, and also you will have here this was the intersection. If I hide the database, yeah, hide all drill holes. If I open this one, now you can see. Also, there is a good toolbar. We didn't put it. Scale and transparency. This will allow you to transfer one. In Servback, you cannot, if you have many domains like this one, and you do transparency, between transparency all. I think they develop another one. You can just select what solid you need to transfer, and the other maybe is not. But for now, in this one, you just transparency all your data. But I think you can select. You just generate a small script, and you can select what. I can see this is the interval that we have inside that string, and can you see it in the section here? You just get the intersection from that drill holes. From here, we just need to go to the composite or extract sample. So to extract this sample, you have two methods. Either you can go to extract sample data or sample data using geology, and this will extract the sample with the original interval and will select the midpoint or top points. But in the composite, will allow you to generate an average length. If your sample interval is not same, you can just make a weighted average for that length and give you a weighted average grade during compositing. So if you need, you can do a downhole compositing. If you are working grade control, you can do bench compositing. You can also have compositing by grade constraint, it's like economic compositing, and also by geological constraint. Then let us go and do the downhole first. Just give it name. Number 1. You can do histogram for the sample length and see what the most common sample length, the mode. And then you can just, if you have sample with length 1 is more than the other sample, you just can rate the composite 1. So you can just change all the samples to 1 meter. Here you have to get the fixed length or the best fit. And also here you have the minimum composite. If you have in the end of the hole, you have left with a small sample. You can have many options here. You can just include it, or you can just include it with the before this one, with the interval before. So from here, we can select no multiple zone, because if you select no selection, you will just composite all the drill holes as one. But for now, we just need to composite within that ore zone number 1. And the sample file should just generate your sample file. If you have more than commodity like AU, you can also put here the copper, zinc, and you can just get it all. This automatically will store in D1 in the string, description file number 1, description file number 2. And here, if you need if you have any weighted field like the sample length or density or anything, you just need to weight the sample with. You can just, otherwise you just keep it empty. Then you apply. Here you need to define the zone that we save it in the with the say in the domain. And if you remember, I think it's VN1. I think that's it's VN1. Yes, VN1. And you just apply. You don't need to do any constraint. So we already have our composite. Let's hide this one and just display the points. You can see now you just get, if I hide the drill holes, you will just get your drill hole with that is all the sample file. To do a basic statistic analysis, you will have tool for basic statistic also. And go from here to basic statistic window. You can also bring it from the block model, the statistics, so I think from the statistic and then basic statistics. This basic statistic window, it allows you to make histogram, cumulative frequency, and probability curve, normal distribution. It give you also basic statistic report. Let us see how it works. It can accept data from string or from block model even. Then you can just come from file here and just load data. We'll just load our Venn data. Then you need to define the D field that stores the goals, for example. Then you can just click apply. Now this is your histogram, and this is your cumulative frequency. And you can see this, the number of sample brought against the values. So you have the highest values here is about, in this vein is about 77 gram per ton. Also, you can display the probability curve. This is the probability of FT trades. If you have two variables, you can do a scatter plots, dependent variance versus independent. For example, if you have two, like any two variables, you can just plot against each other, and then you see the scatter plots. You can see the correlation between them. You can also do your mean and coefficient of variation plots. Also from here, you can see if you have mixed population, we call it biomodel or unimodel. And you can also see define the outlier. So like this value in the tails here is just outlier. You can also generate a statistic reports. Here you have the percentile. You can define the percentile you want, 10% percentile, 20%, up to 97.5. This also defined here, you can see the examples. Just click apply. Then now you get the basic statistics. You have the number of sample, minimum and maximum. You have your mean, you have your median, and the geometric mean, and also your variance, the standard deviation, and the coefficient of variation. The coefficient of variation is just divided the standard deviation by the mean. And this will give you a good idea if you have 100 coefficient of variation, maybe you have outlier or you have mixed population. When you change the, if you change the coefficient, if you remove the outlier, the coefficient of variation will be low, and if you define the population, also will be less. So here you have your percentile for the data. If you have the median, you just sort the data in descending order, and then just define any 10% give you the value. And for here, you can see that 97.5% of the data is below the 7 gram. If you go down, I think we don't have down. So if you can see here, we have many. So the 7 gram of the probability is just lie here. But you have a lot of outlier there. So in order to fix this problem of outliers, you have 4 methods to do this. You can do this analysis. You can use confidence interval equation. There is many methods that you can define what to cut, and you can also use the cumulative frequency to define where is your cutoff. Because if you prepare this data good, we'll have a good biogram. Because if data have a problem here, the biogram you cannot interpret it. It will become very difficult to interpret the biogram. Later on, we can just go and show you, for example, if we would like to, for example, if we decide to get the top cut for this one on which one to, if we decide our top cut will be 42 gram. You can come here from the file tools and then you do capping. This we are not doing top cap, we'll just change the upper value to 42. Then from the file tool, you can just come to the string mass and then you open your sample file, and then you define the new sample, cap sample, and then you just define the D fields, D number 1. So this field here, I just need to store in the same file. For example, I can store the caving file in D2. And if you install in D1, he will just replace the original data. For example, you can use in D2. And then we know that you create the store in D1. Here you have this equation. You just simply tell him if the grade is greater than 42, make it 42. Otherwise, you just keep it as it is. If you need to understand more concept about the string mass and what the expression, you just can go to help. And here you can just get all the string mass. This is very powerful in the string mass expression. You can do a lot of operation in that one. For example, this is the equation that we get. If you need to get the 2D length for the drill planning. See, now we will just have a break for 5 minutes, and then we will just continue. Marwa?
Okay.
Yeah, we'll have a break for 5 minutes, and then we just continue for resource estimation, grade control, and bit design, and also blast design. Just 5 minutes break. Thank you.
Okay.
مرحبا أخي نادر، كيفك؟ سامر محمود معك.
هلا سامر، كيف أحوالك؟
يعطيك ألف عافية، محاضرة ممتازة وشرح جميل، الله يعطيك ألف عافية يا رب.
الله يعطيك العافية، شكرا، الله يخليك.
الله يسعدك. أنا يعني مسرور جدا بالسماع للمحاضرة، يعني أنا ما بقدر أشرح زي ما أنت اللي شرحت بهالسرعة هاي. الله يعطيك ألف عافية.
الله يسلمك، شكرا، الله يعطيك العافية.
العفو، يعطيك العافية.
Okay, Nadir, there are some questions pop up from the audience, so we can take them now. Can we?
Yes, we will have it after the break. Just 5 minutes, and then.
Hindi mo masyadong ma-update.
Yes, Marwa, we can just take one. Because of time, we just take one.
One question.
Yes.
Okay, the first question is
Just one, and then we.
by Sarah Sarat Kumar. Any certificate issue from your side after the session?
We just need to take a technical question. We're not
No
certificate.
technical
Just get the knowledge.
question. In the chat, no technical questions. If
Uh,
anyone wanted
Nadir,
technical.
yeah, I have a quick question for you, Nadir. Like, in case you have multiple domains and you already designed, you know, your solids, is it easy to flag the samples or the composite very quickly, or you need to do it for each zone separately and then combine it together into one database?
Yeah, you just need to. This one will work with the script, so you just need to generate a script, and then you provide the names, and it will be. It's just very quickly.
It's like a macro. It loops over and will.
Yes.
Okay, I see. It's different than Leapfrog. In Leapfrog, you just evaluate the geological model to the drill holes, right?
Yes, and then you just.
Yes, merge them together and done.
Yeah. For example, this you can just loop even for 1,000 load. Loop for 500, and then you just repeat the process for all of them, and then he got that one. I think we will just make advanced session for that one. When we know how to use the scripts in Servback, it will be very powerful, because now we can see it's you just do one by one, but this is not how you will work it in the.
I see. And is it only using what language does it use to script? Does it use any Python thing, or just they have their own language?
They use TCL.
Okay.
Tool command language. They call it tool command language. It's very easy, similar to Python. It's not that difficult.
Okay, perfect. Thank you so much. That was my question.
Yeah, but that we'll do the session this, because now the class is just starting. But we can make a session for advanced, how you make advanced resource estimate using Servback, and how you can do the macros and all of this stuff.
That will be very helpful for everyone. Thank you so much. Thanks.
Okay, Nadir will start, or we'll give another question.
Yeah, I think we better start because of the time. So for now, we make the top cut here. And if you go and load this one, this is a capping. I saved in D2. And you can see that the maximum value is 42. And if you can go and see the coefficient of variations and this stuff, you can see the coefficients just become low. And you need to get a statistic advice from your geostatistician on this one. And then you can move to the next step. We can do a biography. So this now we prepare our parameter for the estimation. For example, also Servback, they have a biogram modeling tools, and they accept also the string. Now we'll just work with the biogram map. Just very quickly show you how to generate a biogram map. You will just get your cabin file for the samples, and you define the D field that contain the calls. You need to define the blend and blend dip to start with. So you just make it 0, 0 to start. And then you need to define number of biograms with increment of 10. If the circle about 36, 360 in the rotation, 360 direction. So now if increment is 10, then you will get about 36 biogram. For example, if you go to 16, you will get about 22.5. You can just start by 32. 36. Then here you have the spirit and spirit limit. I think I have better. This one, this one. People can just understand very quickly. Yeah, just wait. I have this one here. So, this one. Show you. Yes. So for now, we just need to explain what's the spirit and spirit limit. So you can see here you have spirit and spirit limit. It's just this angle. So the spirit is the angle. You can make it, for example, 30 degree, and the spirit limit is the distance from here to here, and we can make it also 30 meter. And then we will make a swath for the sample and just pick and do the diagram. The diagram is just subtracting the value from each other, separated by certain lag, and then square the difference and then submit that difference divided by 2, like semi-biogram. The software will generate automatically for you. Then need to do this calculation. You just start by 20 meter. Maximum distance is, let's make it about 400 distance. We have advanced for the lag slider. After we use the slider to change the lags between the distance. The increments 10, even 5 to be small, so you can see it. Then you just apply. Addition maximum is greater than the height. The height is 400, so this should be 400. Then you apply. Then now you generate for you different diagram. You can do tile here. Then now in this diagram you need to, for example, the first one is to select the strike direction. The strike direction is the maximum range with low variance. So the low variance and maximum range you just need to select. Then you just slide here, and you have this diagram map which show you the variance. So let me just put it here. I think there's a problem. So for example, the plan now is 0 direction 0. So for now, you already know, you can see the strike of this vein is already in between 0 and 90 because the low variance. This legend here from lower variance to the higher variance. So we need to have the direction of lower variance, which means blue, to the long distance. For example, now if you can see here, the direction number 30, we have the lower variance with a long distance, and this maybe can be your major directions. In order to understand this one, it's already set here. This is the direction of the strike. And for now, I think we'll just go quickly on this one, but this will be, we'll explain very well in resource estimation course. Then the first direction you need to set is the strike direction, and we say that you need to define the direction number 1 for the maximum area. You just came from the biogram map, select direction of maximum continuity, and then from here we'll just drag and put it into 30. Angle 30. So now we already rotate. We are rotate that angle to 30 degree along the Z direction. So for now, if you need to represent these directions, you can use your left hand. The thumbs is pointed towards. Let me open my camera. So now you need to use your left hand. So this is Z direction. So now if you are in plan view, then now we already move. We rotate around the Z about 30 degree is a strike. Now we need to go and search down dip, which will be the X direction, and then see the dip angle. Then let's go and see this one. So from now, we just go and go to the secondary biogram map. The first one, we already generate the horizontal strike direction, and then we need to go to search in down dip to see what's the maximum to continuity with lower variance, and then we can also go to the search, which is called the plunge, and then we just convert this to a 3 direction. We call it major, semi-major, and minor. Then from now, you just need to go and tell and just also see. Sometimes this data can be misleading if that is not clean from outliers. If your data is not clean enough. Now if you came here, the direction of faulty, you have the maximum continuity, for example. Just need to select this one. You need the 40, yes, this one. So now we have maximum range, and this you can also, we didn't explain this one here. In order to get the diagram right, you have the nugget, the sail, and the range. It's not right here. So for now, the difference in data in distance 0, we call it the nugget or C0, and the maximum variance, we'll call it the sail, and the range is the distance for your diagram. But now already we'll select that the other direction to be as our secondary diagram, so in the secondary diagram our maximum direction of continuity, and we just came from here and just select this one. And then it was 160, and then we just apply. And then from here, we'll just extract for this diagram along these 3 axes. Then we have these 3 diagrams. So for now, we need to go and model the diagram. You can just use the modeling diagram tool here. And you have many types of diagram model: spherical, exponential, Gaussian. And you can start defining that model. Then you can just go here and start model that diagram. You can add many structure as you need. You can adjust your lag to better fit these positions. And you can see it's already linked with all of them. So for now, you can just get a representation for all the 3. And from here, you just get your nuggets. And the nugget, you can just do a downhole diagram to get the actual nugget. You have the sail, and you have your range, so 67 meters. and then you have your ellipse direction. From here you can get your parameters, ellipse parameters. This will use it for later. For example, this is your diagram representation of that one. This is just quick and nasty model. Once you just generate your diagram, you cannot play with this one because it's just fixed along the major direction, the model. And let us go and just create an empty model and then just this parameter. We will just save this parameter for later use. Yes, like this. In order to generate your nuggets from, just close this one. Let us come here. Let's close this one from background. You have choice to have a downhole diagram. Some of the composites, for example, one, then you have the EU part per million. You can do it for your multiple zone. You can define that zone we defined earlier. And this is VN1, and then you apply. So you have the maximum. You just need to define the lags 1 up to I think 160. Then you put it as test. So this you need just the drill hole information. Then now from here we'll just generate your model. This came from here. Diagram. Just need to model that one. Yes, it's already up here. And then you can get your nugget. You can see your nugget is about 70% nugget. Oh, and this the gold deposit is range from 4.4 to 40% to maybe 70%. If we can zoom, we can increase that one and see, model that one. So I think it's almost, yeah, it's about 70% nugget. So now this 70% with the other still, you can just use it in the parameter when we came later on. Now we'll just move to the block model. You can go and play with this tool. But this tool you need to work with the geostatistician. But for now you can just take it for your knowledge to get this parameter right. So in order to create a block model, we just go to the block model and define what's the block model. So as you know, the block model is just is simple representation for the ore body, and you just need the framework to have a block model. And the block model, the framework is just contained with a lot of smaller blocks. We call the parent block. You need to define the Z, X, and Y increase or extent for that one. And in order to generate a block model in Servback, also is very easy. You just need to have extent. For example, if we put our bit design, and we're working the block model. This is our design, this is our ore. So we need some block to cover all this one. This we call it the block model framework. So the framework should cover all of this data. Close the concept, warehouse, coding. So for now, we can just came here and just get what the mean and maximum coordinates. For example, the minimum coordinate is here. You can guess 1,400 and 7,000. and you need the maximum coordinate, you just need these 2 points and also the minimum and maximum in the Z elevation. Example 260, and the minimum is -20. Then from the block model, you just came here and generate new model. You just give name to that model. But just put the model name here. Then you apply. Then here you need to put that coordinate that you stored before. The minimum and maximum coordinate. Also, you can just get it from string. To see if you have string here. Yeah, we don't have a string. Yeah, we just need the model framework. Yes. I will just copy the model framework so we don't. So now this is a model framework. You can just get the coordinate and minimum max from this framework. So I came here from block model new. Model name. Again, I will just get that from the coordinates framework. Model framework. Then automatically will just fill this information for me. It's basically the minimum coordinate, maximum coordinate, and the upper and lower Z elevation. Here you need to define your parent block size, and this defined based on your sometimes SMU, the selective or single mine unit, or based on your different study. But for now, we'll just make it as 10 by 10 by 10, and you need to also define a subblock so you can have a good representation for your domain. You have many type of subblock, even a standard should be divided by half when you go down until minimum. Or you can just have it variable, so each one they have different set. Or you can just get the free block model, so without any subblock. And free block model we use if you need to import a CSV model from other software. So for now, we'll just keep it variable and then select 5, and then you can make this 2.5, and then we just click apply. Then we create. Then you will find that the model is just connect the bottom here. This have your empty model. So now we have our empty model. In order to fill, the empty model is represent the location of the blocks. You can see if you go here, it's just smaller block 10 by 10. Here we have a big blocks. So for example, if you would like to fill this in for a block with data, we just need to have attribute to store that data. In order to generate attribute is from here, block model attribute. An attribute have many types. For example, AU per million. This can be real or float. Saying float is a decimal. Real, you just define the decimal unit. You can set a background, so you can give a description. Sometimes you have a calculated field, and you can just put the equation here, or if you need to calculate that one. Just now keep it simple for AU part per million, and then we keep it for also density. You can give it default value if you want, or you can just give it 0. You can put the rock. It can be character. It can be integer. Can be put your domain. For example, you can put the domain ticker, like one refer to domain 1 and so on. Also, you can have a background value here. You can keep it empty, and you can have also background value, but whatever you put in background in the character will just make your models very big. So we'll just let us work with this one. Very easy to generate your attribute. In order to install data, so that attribute is different from attribute another. In the gold, you need to estimate the grade based on your samples and your biogram parameters that you generate later. The density, you just assign the value from, if you do a analysis for the density for different rock type, then you just, and model the rock type, you just need to assign the density. I will show you now just maybe some example. The other thing you need to understand in the block model is the constraint. The constraint is filtering, basically filtering the model depend on your data. So if you need to generate a constraint, for example, if you go to new constraint, you have many type of constraint. You can just generate constraint from a solid. For example, give you some example now. And also I can generate it from here new constraint or from that. If I will just need to filter the model according to the ore zone, I will just select the 3DM, that means solid, bring the solid, and I will make it inside. If I click it, that means I need the block node outside that wireframe. Now I just need the inside the wireframe, then I will apply. Then you can see the block is just represent that. You save all the block. For example, now if I select that block, I can flag it inside that model. This is basically how to flag. You just need to define what this volume, for example, this vein 1, you just need to flag it inside the model 1. In order to flag attribute, you just need to attribute mass. If you need to store a character, if you need to assign value, we'll just go to assign value. Now let us work with this one. Let us go to the rock code. You need to make a double quote, and then you write your, for example, if now we need to assign code for vein number 1, so we call it this vein 1. That's the coding, and we need to take this constraint. So now these blocks will be assigned or get the value of Vn inside all that one. I will just came in the constraint and then select that the 3DM, the solid, and yes, I will select this, the ore number 1, and then I will apply. So for now, if I query this polygon here, if I go and query this block, you can see this rock code is vein 1. And also I can go out and also flag the other. I can flag, we have intrusion here. And we have this, the sediments. Then let us go and flag the others. When you start flagging, you just need to just go with geochronology because the block should have one single value, so you don't need to overprint your blocks. So you will start from the biggest unit to the smallest unit, or to the younger unit. I'll just get another example, and then you can just move to the next point because of the time. If you would like to put the density, you just go to the estimation and then assign value. If the density of that solid is 2.76, I will just a density. I will just tell him that the density is equal to 2.76 inside this solid. So I will go from here. I just select 3DM. I'll select the same solid, and this solid we just generate from the beginning, if you remember. Now from now, if I just bring the toolbar for the block model and query this block, I will find that I have density value. In order to estimate the gold value, I will just go to estimation. You have many difference. You can use inverse distance, and this weighted by the distance, the inverse distance. And also you have the ordinary kriging, you have the simple kriging, and you just have the nearest neighbor. But now we just go with the ordinary kriging because we have this best unbiased estimation method. Then here you just need to define your attribute, and then you just click apply. And here, if you need another information for like the kriging variance, kriging efficiency. So you validate your statistic interpolation after this one. You just give it a name. For example, if you need to anisotropic distance to nearest neighbor, you can give NSD, for example. You just put names here. The software will generate this attribute and will populate it for you. You don't need to do anything, and guess you just came and review your estimation. Now we'll just make it empty. From here, we'll just select the vein. If you can remember that vein location. Yes, after the capping, I stored the AU value in D description field number 2, if you remember with me. And I will just simply click apply. Then here this parameter, if you remember the diagram that we worked in before, give us the ellipse parameters. I think we save this one here sometimes. Yes, it's the ellipse parameter. So you can see this parameter will just bring from that one, is 30, 40, and 1. So the minimum and maximum number of samples, you just need to make a study to see the probable minimum and maximum, because some estimation is sensitive to this one. So this one is very sensitive. The estimation is very sensitive to the minimum and maximum sample use in the estimation. But now we use ellipse. We can use also octank. If your data is very close to 30, you can just use octank. If not, you just go with ellipse. Just keep it simple. The maximum search radius, it should be your diagram range. Or you can just make the first pass range is 100 or whatever you have the right parameter for this one. The maximum search distance, also you need to define this parameter. And I will just give it as 100. Here you don't need to do anything. You don't need to select. The estimation should be selected to the smallest unit. You get high variable. So now you get your data from, as we said, from the ellipse earlier, 30 and 40. And we know this one is anisotropy. It cannot be 1, so you can just put 1 to the 4. If you can see the ellipsoid here, this define your ellipsoid. There is many software you can use to generate your statistic software is very easy and very helpful to generate all this quick estimate and also robust parameters. But when you get that parameter like the interpolation through Servback is very easy. You just need to go through this process. Then after this, you'll just click apply, and then you'll go to the diagram model. If you have saved that diagram model, you just open it from here. If you don't have the data, just put your nugget. I think that nugget is 70%, and the cell I think is 90% something. Then you need to define the discretization point. Also, you can optimize the discretization point per block. And I will just keep it simple. You just need to give it this for the report name. Estimate number 1 nodes. Then you need to constrain the interpolation. So now we don't need to just estimate all the model. We just need to estimate inside that ozone, because the sample we get inside that ozone, and this we call it hard boundary. This now we call it hard boundary domain, because this is load and vein deposit. If the vein deposits is, you can just use like this. If you have a disseminated or VMSs and this stuff, it's just different type of like soft boundary. You can use that one, or even you can use advanced statistic like MIK and others. For now, we can just do apply here. Then, as before, we can just use to estimate inside that solid. And then we just add that one. Then we just apply. Yes. This is the report of the estimation. You can color the grade after you populate it inside. Example 0.3, 0.5, 1, 2, 3. this after we estimate that gold grade inside this one, and you can validate this estimation in sections. So if you do section, you remember the section we saved from before. So already now we have these blocks, and from here you can shrink the block. You can define the shrinking value, for example, 50%. Display it. You can also make it empty from here. Based on, you can also see the value inside it. Now also you can bring your composite value. This is our composite value here. Here's display for you. And then you can come and compare your estimate with the actual value here. Let me color this one. In order to color the string file or classify, you can just come simply here from file. And then we classify. So we have the same color with the block model. Then you select your sample data. Yeah, description field in number 2. Let's make it 6. Sample C. Let's find field something here. Yeah, we don't need to classify by field. You just need to classify it as it is. So it's it is range. We already defined the range, points, classification bus, just one. Yes. So now I already classified this one and save it here. Classification is just classified by different grade boundary, so I can just visually see the difference between the grade. I will just hide it. So you can see I'm working in the active layer here, then display it. And display the D field, the SIMD number 2. Select yes. So we get here the estimation 1.17, but this is get 2 gram because of this. You can see this 3 gram effect on this one. And then you can just go and validate your all zone. And also you can validate this against your drill holes. And as you can see, if I remove all this constraint, you can see the grade boundary is not populated inside this one. And you can see because of the block size, I have smaller blocks. So maybe this block is 5% inside, but it's already get resulted. But if you have a good sub blocks, for example, like this one, you need to select a smaller sub block, so you will get actual results. Then this is your estimation. You can see this is your high grade vein. You can see this is your estimation. This is also another zone here. You can go to the second section. Also, you have waste inside this domain. These are waste samples. You can go and validate. Also, you can generate SWAS plots for validation. You can just come here and generate a SWAS plot. You just provide the composite file. D field is 2, and this is the goals. Density, AU part per million. We call it also estimate. You can see the SWAS is northing. We'll start in the interval is 40. Start in 7120 until the 7600. Just apply the constraint. Save here. And that's it. I think we just to apply constraint again inside that one. And this you need to repeat it for all your domain. So for now you can see we have this is SWAS blocks. You can see now The blue one is your values, and the green one is your estimate. And you can see this plots. So this is different ones. This maybe you can validate. You can also validate by level easting. You can just go and work with that validations. Here you have the reports. Also, you can generate your grade tonnage reports from also here. Grade tonnage reports, report, CSV. Yeah, you need to define your cutoff. 1, 2, 3, 4, 8, 1, 2, 3, 4, 5, 6. Apply constraint. Density. As your decimal. Open chart. Then you have our grade tonnage reports. Also, you can make many analysis here. The multi-domain analysis, this box and V6 plots. And also you have many estimation. You can go and do 3D kriging, indicator kriging, this MIK. For kriging, you can do normal score transfer into Gaussian. And also you can do sequential Gaussian simulation, sequential indicator simulation. In this also you can work it very easy in Servback. Also this data you can just transform to Gaussian, and then you do the diagram. It will be very easy, and then you just back transform. And if you do, there is many statistic software can do this one. And this GSLab is famous for library. A lot of software they use this one, not only Servback. Then here you just need to reporting part. If I need to report and see how much I have inside this one, rather than this one, the grade tonnage report, you just came here and do reports. CSV and just came to, for example, R1. Yes, you apply. Yeah, let us make it with constraint. Then here you just get your AU. If you have many estimated attribute, you can just select it from here. Otherwise, you just go and just select your density here. You can just select your cutoff. For example, if you are reporting in cutoff 3, you can also select what rock type you need to report in. Also, you can use volume calculation. Also, you can use what you call this partial percentage. For example, you remember before we have big block, just 5% of that block inside. We can also tell the software to include all that block or just include percentage of that block. Then here you just need to select what the rock type you need to report. V1. If you need to do a constraint, you can just constrain. Otherwise, you just press OK and then wait for the reports. And now we have the reports here. About 6 million ton with average grade 1.7 for that, for only that. I think from here, there's no problem. I just need to show you how to constrain or how to flag above certain services. Because now you already know how to flag inside service. For example, if you need to flag the level above this design. Also, it's very easy. I just need to see where is that design located. Yeah, we design. Or just go on new constraint. You just select DTM as service and you just select your service like this. We design here and just select above. If I select that below means select above and then you just apply and you'll get that one. Color by this one. If you do your section again, then you can see here. You can see you already, I remove this one. Just zoom out here for you to better see. Sweet. Hide the drill holes. Hide samples. Then now you can see here. You can also show you your value if you want. Center. Then now you can see we already click by this one, and so also you can click by topo. If you use DTM and bring the topography, you just tell not above that topo, and then click by your topo. You can go different section and section, and you see how that one populated, and also you can see for the others. And if you go zoom in, you can get your value. You can also color by your density. You just need to see the density value. Then you can just get and see the density. So you can see it's colored by density, but then the number inside is not the density. In order to get the number inside as density, you need to go and draw the attribute here. You select density, then apply. Then you get it here. You don't miss and plot this one. If you'd like to plot this one, you just go and plotting. Yeah, you know auto plot for this one. But you just go and auto plot, and then you can just auto plot that one. It's very easy. You just select the interface and just you can plot it in A0, A, or any paper you need, or you can just save it as PDF. So I think from here we better jump to the engineering tool, how to do I will just show you a quick example how to do a grade control. The grade control mainly from blast hole. Most of the mine they use a blast hole. And here we are not covering the underground, but underground also is very easy. It doesn't require any rocket science because you have the stop optimizer or stop design. And this just you would put the section for the block model as it is and just draw your stops and then define your pillars, ground pillars. Then you have your underground design for decline and all this one. Then you have your ring designs. Can set up it and also do all this one. It's very easy. I think they have documentation for this one. We will cover this in separate session. If you need to work with grade control, the grade control you need to have a master model for grade control, either from also Servback they have separate model for grade control. That one also is very easy. It's just menu driven like script. Now I'll just show you how to do it manually, and also I'll show you how to use the grade control polygon method here, but it's not recommended, the polygon methods, because you will have a lot of estimation bias and you will not get accurate information. But if you need to use the block model or control model, you just go quickly. Let's go for grade control very quickly. You will have a database grade control. For example, if you have bench, so if you have this bench here and you would like to generate a grade control for that one, you need first the engineer will design a drill and blast pattern like this one. Then for you will just go and get you will just go and get some samples from this one. Is a if this blast hole sample, you just get a blast hole sample. Then you need to come and do composite using that bench elevation. You just define your range. If you have a lot of database, you can just define your range. Otherwise, you just select the level that you are on, and then put your grade range. For example, bit of 1.99. Your attributes table. This practice is just very easy. And then you just apply. If you have a block ID, you can just select the block ID. For example, if this block, just select whatever the block ID is. If you don't, just apply. Then you will get a composite. I will just show you the first method very quick. If you have the samples, you can just open the file sample from here. Yeah, you just go to design, create control, open sample file, and then you just get your sample file. This one or this one? I think this one. Then is point data. You need to define the safe fields. Number 4, the thickness of that is 10 meters. You need to get the specific gravity. Let us call it 2.8, and then you just apply. Then you have your data. You just need to erase the sample ID from also design, create control, and erase the sample ID. From here, you can just generate dig polygons. But as I said, this is just example and not recommend to work with this one. If you just draw a dig polygon certain level, also now we'll just go back and use the same digitizing. I don't know where I put that. Yeah, this one. The same digitizing method as before. We set the elevation to 120, and then we digitize polygons here. For example, here. In close. Yeah. No. Yes, in close. Then if you came here and do a, and you can see this is in the bottom of the pit. For example, we are working here in this pit, in this bench here. You can come here and see what is the average grade and tons in this polygon here. And just came from design, create an average grade of polygon. Then you just select, and he'll give you what is the average grade, what is the mass and tons, and this one I can just populate this one. The other way is very quick. We need to take it quickly. You need to have a master model. For example, if we use, we just copy any model from here. No. If you just use this core model here, and then you just need to go and see what that area location is. Is that one? Yes. So now we need to know what's the segment number for this one. Then you need to go display string with segment. You display string with string and segment number in the center. Then I know this is the polygon here is string 2, segment 2. I just need to create a small block model for this area. I will just go from block model, open new block model. I will bring the master grid control model, and then I will block 2, for example, then I will apply, then I will import all the data here, apply, import all, apply. Then from the constraint, I will just use that string. Let's call it a bench. That bench, I will just say segment. I need segment 2, string number 2, and I will put the level. It's 120 to not above that level, 110 above this level. Yes. No. Then the software will generate just block for this area. You can see this is just one block for the area that we request. The big design is here. So now we just need to generate a grid control for this area. We'll just come and estimate that area using estimation, ordinary kriging. Just estimate that one, or we can just generate attribute for grid control, OCM. Real to decimal, and then we just apply. Then from here, we just need to estimate using that plus samples. We'll just go and estimate ordinary kriging as before. Same step as before, but now here we need to generate, we just get the sample and also flag the domain if you have different domain in this class. For now, we'll just make it as one estimate. The grid control sample. This is our sample here. And apply. And here you need to optimize your search distance. It cannot be 67. Maybe you can just go with maybe with 12 meter. You just keep it as it is. Same. Let's estimate to 2.5, and then we apply. We can use the same as previous parameters. You don't need to, if you have a domain, you can just constraint as that domain, otherwise you just apply. If you have any domain that assigned here, you just the or domain from grid control, you just save it here and constrain the interpolation site. Otherwise you just click apply, then you have generated your OUCM. I think there's something wrong here. You just need to see the sample file. It's not this one. No, it's this one. Yeah, I think these are samples. You just get the wrong samples. This is the samples called bench 115. Let's go. I'll just repeat it very quickly. I get the wrong sample file. Then the sample files would be this one. Then apply. Same as before. Just need to change this one. Apply and apply. Yes, apply. Then I will just come and color this one, and then you need to validate your estimate. It's not just apply, you just need to validate. No, even there is some problems. Let's see what's going on here. Yeah, it cannot be this one, so we need to see where we are storing where the gold value being installed. So the gold value is in D1. The gold value is in D1. Yes. And the sample is already set in here. So just estimate again. CM is good. Yeah. This is a problem. We are estimating from the D2. We need to convert the D1. So it's getting the sample name as estimate. So now you need to make sure that you get the same description field that install the sample data. I think after this we don't have a problem. Yes, it's good. So now everything is good. Yes. Just make this to gray so you can see. Now this is your estimate based on your samples. We just need to see our sample. We can make section in that level, elevation 155. And just make it as 55. Okay, we can just put it in center, and then we can see our sample. Let me just open the sample. Yes, so we can just validate our grade with. Also here you need to understand what the so for now you can see this is the estimates within your samples. So this block is 2.39. It's getting from that sample, and this will tell you sensitive to the minimum maximum number of samples you will use inside that ellipse. From here, you just need to go and digitize your dig polygons as before. You just generate a layer and just start digitizing your dig polygon. You just digitize whatever you see as ore and divide based on your cutoff grade. And then you just need to save this string and flag inside this model and then report it. For example, you can report this one and you can report all of this. That's I think this is all for grade control. You can just if there is more information, you can just provide it. So because of time, you just need to jump to the drill and blast design. Drill and blast design is also not complicated. You can just use the previous example. You can use the drill and blast design also to make acceleration planning or drilling planning. It's also a good tool for using that one. For example, if you need to create a blast design for this one, you can just get the blast menu, or you can just get the blast toolbar from here. Or is from the design, you can just get the blast design. So for now, we just need to generate a blast hole inside this one. You just need from the blast design, blast button. It's also not license. Yeah, this also you just need to, you can just generate let me just fix the problem of this one. Just wait, let me just check. I think this is I think this can work now. Just try this try. You can just generate a plus design. You can just drag and drop, drag, and then you need to define your bearing and spacing. You just need to press Control and you rotate. After that, you release everything and just you move until you locate that segment inside your areas. Because now you don't worry about the box is very big than the area here, because we just constrain the polygon. Once everything is set up, your bearing and spacing, you just click enter. Here you just need to define your parameters, and this parameter can be defined in the blasting setup from beginning. So drill and blast setup, and then you set up everything. And then from here you just come and select. But for now we just make it very quickly. The bearing and spacing we can select is to be 3.5. Example 4. You can get the data. Here you can fill the informations. Here also you need to fill the whole bearing. So the blast hole is just vertical. Bearing is 0, it's minus 90. Whole diameter is set. The whole diameter is good for calculation the quantity of the blast material, like the info and this stuff, and then you can just generate a cost report for your blast. Here you can use a fix, or if you have a DTM from previous months, you can just select it from the main layer, or you can just make fix elevation 120, for example. Also here you can just set length 10 meters. If you need to have a sub drill, you can just find the sub drill. You can give it prefix and name. Later on, you can just work with this one. I will just quick demonstration. Then we need to select our string. So now we generate our blast polygon and the level that we set up. If you need to move or delete some of the point that not required, you can just delete it from here. Otherwise, you can just keep it as it is. You can also have option to upload this to database. You can just open database and just upload this placeholder to database. You can display same as database. You can delete, if you just need to delete single hole, you can just come and delete. And also you can delete, this now is as a segment or string, but with this style as a placeholder. You can move single point, you can move group point, you can charge. For example, if you tell him to charge all the drill hole, now you just need to have your charge plan, how many meters to the stemming, what's your charge info. So this information you will just store it in the drill and blast, what the explosive that you use. You will just fill all that one, and then when you finish, you just click apply. Make this to and for example, we just remove this one. We just need to fill all of them, of all information. It will give you reports, and this one will be stored in the blast database. After you generate the blast database, we'll just import all this information or upload this information to the blast database. Then from here, you can also see the firing sequence. Where is your initiation point, and then you can just go through the firing sequence. You can generate the firing sequence. Example, can I generate in? Let me. Then, for example, if we just use sentence, so you have 3 pattern of output layer is sequence 1. And you can just come and initiate that point from here to here, for example. Then for now, we can just go and see the animation. I think there is animation here. Then animation, active layer, and then you can see how your plus will go. So this is good for plus engineers. They can set up whatever they need. But this quick overview on side this to understand. So now this is I think it's play very slow. Then after this, we just go quickly for the blast design in the last 15 minutes. In real, it will go is in milliseconds. It's very quick. Now here you can adjust the point, and also you can also make a pre-splitting. Let me show you how to pre-splitting. If this finish, yeah. Now you go to all the samples or the plus hole. For the pre-splitting, you can just go here and you can see pre-splitting hole along line. You just need to have a segment. And after you plate this one, you just need to select the segment. You will define the pre-splitting and just select the spacing between the pre-splitting and the angle as before. Just now go to the final thing. Bit design, and also it's very simple here. Can just work with this model. Or I think we better just work with a bit shell. For the bit design, you will just have a bit shell from Whittle like this one. After you generate your resource model, you will hand over to the engineer. They will do the optimization study, and they generate a bit shell, and then they came and design this information here. You need to start from the lowest point here, or I think from upper here. First thing you need to get the design parameter like the overload angle and this information. For example, now here you can design by 50, and you need to know the number of bench, because the design angle in the Servback is not the same as the overall slope angle. To define that angle, you just need to come to the bit design and expand segment multiple design. You just need to select that polygon. You just need to have bench. So I will just make a section in that one. Patient sections. Let us go. Yeah, we just gave this 5 minus 100. Step is 10 meter. Bench. So now this is our first bench. We just need to generate a new one. Design. Then you can just easily came here. You can see now this is a bit shell. I will just now draw a rectangular from the digitizing, and now I'm digitizing the level at 1000. I will just generate one here, and the other one is here. For example, here. So for now, I already get that bottom of the bit. I just need to smooth it a slight bit. Just this one. Then I will display that level here. You can see this the block that we are already colored by AU, for example. You don't need to care about the model. I will just need to see. I just want to see the block size because you already have the bit shell, which have all the economic parameters. So for now, I think the block size is 10. So for now, we need to use a tool. We call it. Here we need to create a curve and tangent, so we can smooth the edges in the design, and we need to define our ramp. And also, in order to make that curve smooth, you need to be in the insert point mode, and then you can come here from create curve from tangent, and then you just start to click first point, second point 2 times, and then the third point. And this you can make it. If you need to have if the block size is 10 and your curve is very small, you can just make it as 5 meter for the radius, and also 10% from that one goes to the arc distance. Then you just apply, and then you can see it's already defined point for you. In order to make the design very easy, you just make point. Then now we need to have curve also here, and if you can see the block model. So now we are already getting that blocks here. Let us go and get that block. Just need to smooth this one. And again, we just press here, 2 point here and then here, then apply, and then we have this one, also this one here, and then we have our curve. This one here. Then for now it's ready. So we need to define where is our ramp axis. If the ramp will be axis from here. But before all of that, we need to go back to the design tools and defines how many bench we need to know what the. So if our bench height is 10 meter. So you can see here we have, this is from 100 to 0, this is 10 bench, 20, about 30 bench height. So we need to go here and just define our multi-bench using this string here. We just go here and say auto expand by height. This step, we need to see what the design angle required to get the overall slope angle. Number of which is about 30 bench. The slope we need is about 50. We need this slope about 50 to be in the overall slope. Let us see, the bench height is 10. So now, in order to get 50, you just need to play with this figure here. Design with 70. So if we design with 70, we will get about 49.2 drilling angle. Overall slope. So we'll just make it 70.1. Even 71. 71.8. So in order to get 50 degree, we need to design by 71 slope angle to get overall slope of 50 degree. So now we go and set up we come here from design. The design slope is select slope, design based on slope. You can also get this slope. You can also have different slope angle for different wall, and this you can use the slope stored in the block model. You can store the angle in the block model and just select the design from the block model and define your angle here in the block model. But for now, we design the slope. Next, we need to go and set our slope gradient. The slope gradient should be 72.1 angle. You cannot put the overall slope angle here because in the end you will not get that 54, because now we need a slope angle of 50 degree. So we'll design by 71.1, and now you can say it here, set up it here. The second step is go and define your ramp. You need to define your ramp, new ramp, and then the ramp require 2 points. I just need to delete this point because they have problems. So now you need to define your ramp. Automatically you will get the ramp width. Also you will have a minimum design for ramp width based on your loading and hauling plan and this stuff. You just need to design. Now we just keep it as it is. So now in order to get, you have three choices. Either this go clockwise or anti-clockwise, or just goes up as all cut. So in here you just, for example, now we are going anti-clockwise. And also you have many parameters here for the beams, how the beam open with the ramp, if it's in the crease or the toe on both. You just need to decide this based on your preferred design. Beam taper distance. This is the cutting distance between the ramp and the beam. So the beam is go 20 meters and then it starts the full beam, because you don't need to narrowing the ramp. So you need to have a good distance here. Then the switchback angle is 180. You can just define it as we goes later. Then let us go define our ramp. So for now we can just build our first bench. You just came here, expand by bench height, and just select this one. And the bench height is 10, and then you need to go up. So now we are going up and we expand. If you design from top down, you just go down and contact. Then once you click apply, you will figure out this one is already start going up. But for now, our ramp also starts. If you can see the ramp here, the ramp also starts going up. So now we need to go and design our beam. I will design our beam and then I will show you how to permits. So now the beam is maybe 10 meters. If you need to add a switchback, you just click here. He will add a switchback for you. Then now you can see it's already add the switchback, the beam. We need to go and expand. So whatever you have this right, everything will be right. For example, we need to smooth this area here. In order to edit this one, for example, if you need to edit, you cannot edit you need to edit this one after you create your berm. Let's just create the berm quickly by berm weights and select this one, expand, berm is 10. So now we already have our berm. So for now you can just modify the red line. You cannot modify the blue line because blue line is controls over overall angle. So if you have widening areas here, if you can go back and see where is your, so you can see now we are already goes behind the bit shell. We just need to make it slice them. So you need to go and verify one by one until you go up to the top. So always when you get bench, you need to modify it, and so on and so on. Then you just build the bench up again. And then you can see we are going down, we are going up. You can see it's just rotating. Then which we just get 10. Let us add switch back here. And we just expand by perm. I think this we did perm. By perm width. And then we add switch back. Select the first. The first and the second. You can see we already have a problem with the string. The string is not smooth. Maybe because of the tangent from the beginning, but this can be fixed. You just need to use create a curve from tangents, and you need to make sure you have you are working the insert point mode, and then everything will be set good. And then you just build this up. And also another thing, you just need to make sure you design to the required angle. You need to do this test, or you can calculate it. So yeah, the engineer have equation to calculate this one, or just come here and calculate it by the software to get this overall stop angle. Enter here will be stop here because now the time is over. And I hope this was helpful for a lot of people. We don't cover the engineering very well, but we can have a dedicated session for this one. Also, you have the Servback documentation. All this is already documented. You can just go through it. I hope this one was very helpful, and thank you. We can get the question if you have any question now.
All right, thank you, Nadir. Now I think some questions pop up from the audience. The first question, a technical question from Mr. Samer. He said, is it easy to regularize a sub-block model in a Servback?
Yes, we can regularize the sub-block model. It's very easy. You have two ways to regularize the sub-block model.
Okay.
So now we'll just show you here just very quickly how to regularize the sub-block model. For example, this model is sub-block. You can see this is regularized. Let us go and see sub-block model. Just very quickly. Yeah, in the create control, you can come here from block model. Then you can convert a reblock, and you also have simple reblock. From here, you just select this one. You need to define your model. It will open the model, and then you just put the parent block size. Yeah. So now you need to just define your attribute you need it. You need to click the attribute you need, and then we define, and then you go and reblocks. Then now you need to define your target block. If you need to reblock, for example, 20 by 20 by 20, and then you just create reblock and then save the new block. This is a regularized model, and you will just go averaging and combine different models. You have also another one, simple reblocking. It's very quick. You just put the model and then you will just regularize. So the next question.
The next question of him is: there is any automatic bit designer in a Servback?
Yeah, yes, this is automatic bit design here. So you just multi-bench design. You just select your segment as before. And then design. Yeah, once you put your parameters here and you click apply, he will generate that one for you automatically. You don't need to go on one by one, but it's preferable to be a robust design. You just need to work it out because it's not you need to have a lot of the shape is not just a radius shape going up. You have many different bench with complicated shape thing, because you can see the shell here. I think yes. Then the question is yes, you can just use it here.
Okay.
So
Abid raised his hand. I will ask him to unmute.
Hello, can you hear me?
yes.
Okay, yeah. First of all, I'm just a data mining engineer, but never had a opportunity to learn Servback, and it seems really interesting. And I wanted to learn. My question is actually I missed the first session, and is there any training sessions that you guys can provide for someone who wants to learn from the scratch?
Yeah, we don't have a training session. It's just like this one, just overview. But if you need a training session, there is many training session. You can go even to GEOVIA. They have a training session for that one. But for us, we just like this one is just free session. You can also see the recording just to let you start. But there is certain training center they provide this.
Actually, I'm in Pakistan, and I doubt that they're gonna provide any setting here in Pakistan. Actually.
So you can just go with online training. There is many online training for Servback. I think we can make one Servback online training with when we need to coordinate this with GEOVIA, because you need to get license.
And what about the software? Where can I get the Servback software? Like I think it's paid, right?
Yeah, yes. You just I don't think so. They have academic or they have academic license.
Okay.
You can contact with them, and then they can just.
All right. Okay. And what about the presentation and all this video? Can we get this? I think this is gonna be helpful if we work on this one. The video.
Yeah, this is presentation is from GEOVIA. I don't see. I just need to ask them if we can just send it. But,
okay. Sweet. Thank you very much. That's all for me.
Okay. Thank you.
Okay, Nadir. There is no one raising his hand, but there is a lot of questions in the chat box. Okay. Sorry, Said, is it possible to have data used here to sit Servback, please?
The question is?
I will send it to you.
Data is used here to set Servback. Yeah, he asked regarding the data. This is also is just demo data. We can just give it to you and can just share it with you. You can just use it. This came with the Servback. If you install Servback, this one will automatically install. It's just demo data in Servback. It's designed by Servback. You can just find it. But if you want to just send it to you, it's just demo data.
Okay, second question. Will you cover the block modeling of underground coal mine?
Yes. You can create the block model can be for underground or for the underground or open pit is just mining methods. So for coal mine or even for the queries, that is a C model. So like the coal mine and the query, they have a big block models. So we'll have a big block size, and also is you can generate a block model with that one. But if the area is very big, the block model will become very huge, and you cannot work with it very friendly. But if you make the block size very big, after you optimize the block size, you can just work with the query and qual. I think there's no problems. And even for underground, you just need to optimize the subplot, and you can get actual representation.
Okay, next question from mine engineering. How to make mine scheduling without Drillhole?
So for mine schedule, you need to use Minesheet. So in Servback, you cannot do mine scheduling. You need to use Minesheet. Minesheet is very easy. After you flag, so for now, we bring the block model and we flag our material class. This block model will be imported to the the mine sheet, and then you define your material class, and then you define your destination. You can make scheduling. We can make session for that one, the mine sheet. Also, mine sheet is very good software, and from there you can just generate your short-term plan. So, and for the long-term plan, you need to use Whittle. So the three software, Servback, Whittle, and Minesheet, is just integrated. You cannot use one other without the other one. So you just need to go and do the scheduling in Minesheet, bring it to Servback for operation, and you can optimize the life of mine in Whittle. So any question?
No more questions. There's one, the last one. Do you have any comment in MATLAB, Vulkan, and this week mining or mining software? You can see it.
Do you have any comment in MATLAB, Vulkan? I don't know what he mean by comment, but this week and Vulkan, they are also very powerful software. You see all this software like Vulkan, Maptic, Deswik, Mindsight, they have the same concept. So whatever you learn one software, the other one is become very easy. You just need to know the syntax and this stuff. But all they have the same concept.
There is one question, but I don't know if you can respond it. What is the difference between Servback, Micromine, and Datamine?
I tell you there is no difference. So the Servback is used TCL, Tool Quant Language. Datamine, they use Fortran and they use JavaScript. But any software, they have their own strengths and also their weakness. And Micromine, as I tell you, they're all similar. For example, now Datamine is good in combining model and this stuff. Even Servback, you can do combining model. But I think Datamine is powerful on that one. Micromine also is good. They all now start implicit modeling, like Micromine and Datamine. They are all good software. You just need to the one you like and maybe the one cheapest to use.
Okay, thank you. Mubarak is raising his hand. I'll ask him to unmute.
Assalamu alaikum. Thank you, Nadir, for the very fruitful and outstanding presentation with a detailed explanation in this short time window. Thank you very much for GeoData for making this happening. My question is, can I rely only on Servback to do a full and robust resource estimation? And to use it solely as one platform without using any other assisting software in the resource estimation? And also, what are the weaknesses of Servback?
Okay, so you see, for now you cannot just use one software. Apparently you can, because they have all the tools, but for validation and this stuff is very difficult. And now you can see all the companies are joining venture. So the big companies buy small products companies. Like now, Datamine get a Snowden supervisor for statistics, and also like the other one, what you call this? They get GeoVariance, the IZT software. So in order to get that diagram right and this stuff, you need to use a statistics software. For the modeling, I think you better use Leapfrog. For the implicit modeling, the best software you can use, implicit modeling. Also now, Leapfrog, you can just do estimation in Leapfrog, and I think is the best software to do estimation now is Leapfrog Edge. Servback is good for operation. So if you are in mine operation, it's very quick to make job with Servback. Reporting, everything is very easy and very straightforward. And it's also easy to use. So maybe you just prefer Servback. So we can also use Datamine. Datamine, they have different products, Datamine OP, Datamine UG. They have many, and you can use this also for different type. But for your question, yeah, I think for me, you cannot use just one software to get a good results. You need to validate, and you need to get statistics software to validate, and you need to get implicit modeling software to make robust geology modeling, because you see all the estimations rely on the geology modeling, and also the geology modeling rely on the geology interpretation. So I think the geology modeling should be the, you need to pick, for me is you need to pick leapfrog, and leapfrog also is dangerous if you don't know how to use it. You just need to make how to know how to use leapfrog, and then you can use it for, and then from that you can pick any software to do the estimation, GEOVIA, Surpac, or Datamine, Micromine, or Volcan, or even MineSight.
Good. Thank you, Nadir. And how good is it in variogram modeling and analysis? Is it recommended to use it for the variogram modeling, to use Servback, or do you think there are some other softwares that are stronger than Servback in this?
Yeah, there's many software stronger than Servback, but you can see Servback is open source on this one. They use the GSLib library, and then you can just, if your data, for example, now the demonstration data is very clean, but sometimes in order to interpret that variogram is very difficult. You need to convert it to the Gaussian, and then you run your variogram to see, and then you just back transform. And this all is manually did in Servback. You cannot, but in other software it's just term of click. So in here you just need to have a good knowledge on Servback, and then you can just use the variogram. Because if you have you don't have a good knowledge of Servback, you cannot use the variogram tools. Otherwise, you just get not optimized parameters. Also in the KNA is just manual in Servback. But in the other software, is just static software is just set up for this one to optimize that parameter. For example, now if you need to optimize the parameter, it's just manual and just script driven. You just need to know how to script in Servback, for example, to do KNA, block size analysis. Is just, if you don't know scripting, it will be time consuming. But in the other geostatistics software, it's just easy to use.
Okay, thank you, Nadir. Thank you for the time and efforts.
Thank you.
One last question from Danny. Said, have you ever used XPAC solution?
XPAC, this is RBM. So Danny, have you ever used XPAC solution? This is, you mean this RBM software? They have good software, I think, RBM company. Yes, RBM company, they have good software for scheduling and stop optimizing. I never use it, but I use I work with some of the model that generated by experts in scheduling. I think it's good. They have the same concept, but I think yes, it's good software. But it's not popular. I think it's just in Australia.
Okay, I guess that's it. Okay, there is another question.
So for the blasting, also for the blasting, there is a software called SimBlast. So the blasting, I think this is the cheapest and also good software to work. And yeah, SimBlast is good, because somebody asked regarding the blasting software. You just need to get SimBlast license. I think they also have the training, because you can do a lot of analysis, fragmentation analysis, a lot of blasting analysis in that software. Then the SIM. blast. I write it in the sync blast from IJK company, I think IJK. An Australian company called IJK. It's also good. So that's it. Thank you for joining. Thank you, Marwa, for leading this discussion, and thank you all for joining us. We hope to see you in another session. Thanks.
Thanks. It would be great for the audience if you could take a few minutes to provide some feedbacks about what you liked about the webinar and what topic and software you would like to see in the future in LinkedIn. Thank you all. Bye.